Good day, everybody. Yes, my topic for the presentation for the annual symposium on climate smart agriculture, optimizing crop and soil production system. My topic is yesterday, today, and tomorrow of agriculture. Yes, and what do I mean by yesterday, today, and tomorrow of agriculture? So the yesterday's agriculture, we're looking at Green Revolution, which occurred in the 1950s to 1960s. This Green Revolution included increased inorganic fertilizers and agrochemicals, use of hybrids, increased use of water. Of course, this resulted in increased yield, reduced food prices, reduced deforestation, but it came in with negative impacts. For instance, there was loss of indigenous food security systems, which culturally communities in the respective cultures had their own production systems which were climate smart. There's increased environmental pollution from your fertilizers for agrochemicals. Then also it increased pest and weed resistance to chemicals. Those are the negatives impact of the yesterday's Green Revolution. Yes, then what do we have as of today? There's aspect of acceleration of Green Revolution, which further increased use of inorganic fertilizers, increased use of new agrochemicals, use of new hybrids, increased use of water. Of course, we continuously have increased yield, reduced food prices, and reduced deforestation. And of course, we still have the problem of loss of indigenous food security systems. There's increased environmental pollution, and that resulted with the loss of fresh water, be it for drinking, for agriculture, for sustenance of life. There's continuously increased pest and weed resistance to chemicals. And currently now we're also facing the aspect of climate change, which exacerbate the above negative impacts of the Green Revolution. Then what are these current challenges? First of all, we have to have an understanding what is climate change, what causes climate change, what is the impact of climate change, and what is the climate change mitigation, and what is climate change adaptation. These are issues which we see as critical risks that we should respond to. All right. So, what is climate change? Climate change, is simple change of the climate is experienced by human. It disrupts the normal habitat of human beings, habitat in terms of where we live, how we cultivate, our environmental factors like availability of water or the aspect of consistency in availability of water. And this occurs as a result of the creation of the blanket around the earth, as you see tried to depict here. This blanket sort of forms a seal around the Earth's surface that any heat generation on the surface is trapped as an effect of when you're sleeping in the blanket, then the heat the body generates gets trapped by the blanket, and that creates your warmth, which sustains you for the night during the cold periods. So the heat generated on the surface of the Earth is in various aspects. You're looking at the industry, We're looking at the various forms of agriculture production systems, which sort of emits your livestock, emits methane. Your chemicals, also emit methane, which destroys your ozone layer. So the aspect of carbon dioxide from industry, carbon dioxide from various agricultural deforestation processes, this would have your carbon dioxide creating that the blanket around the earth. The methane is the aspect of destruction of the ozone layer, which allows your UV, which is not suitable or hazardous to survival. Depiction, we have the red depicting your CO2 emissions, then you have the green depicting your sequestration of CO2. The red, most of the emissions of CO2 is from industrialized countries, and you can read that green, looking at the forest cover, which is mostly with developing countries. You're looking at Brazil, you're looking at tropical Africa and subtropical Africa with the savannas and different forest ecosystems. So we do more sequestration than the developed countries, but the developed countries do more emission. Right? The impacts, however, is shared, despite that we developing countries emit less. And the irony of the matter is that most of the developing countries don't have the means financially in other ways to adapt or survive the impacts of climate change, be it floods, be it droughts. So that's where the challenge of scenario of the climate change. When you're looking at different ecosystems, we have these forests which are the sink for your CO2. And then this was the source for your CO2 and the other gases. All right. Peter demonstrated the photosynthetic activities where your CO2 is taken into the leaf, and through photosynthesis process, you sequestrate your CO2. These are in short to be our carbon sinks, which most of the developing countries are very rich with. Okay, so which are the different ecosystems? You have the tropics, if there's the savanna type of woodlands, which most of the southern African region would be, sub-Saharan Africa. Then you've got the equatorial area where you're looking at your Amazon basin and the tropical Africa, where, in terms of metric ton of carbon per hectare, is they're looking at 300 and something metric ton per hectare, as opposed to the savannas, which is 21 metric tons of CO2 per hectare in terms of sequestration. Although the savannas seem to be quite lower than the tropics in terms of amount of carbon sequestration, in terms of the area and the amount of sequestration in terms of cumulative is still significant in terms of mitigation of climate change. All right. So we have your technology, which like transport, mining. Those are the aspects which you're looking at. We can work on in terms of mitigation, improved use of clean energy, improved technology in the mining to reduce emissions. Then the renewable energy, you substitute your fossil fuel energy with your solar, your wind and hydro energy. Of course, the aspect of nuclear energy comes in. And then in terms of improved land use and reduced change in forestry, in short, loaf progression systems, which will result in the reduced emissions of degradation, forest degradation and deforestation. Then we can aspect of doing the reforestation. All these are avenues that we can intervene in terms of mitigation of climate change. Mitigation being make corrective measures in terms of reducing CO2 from the atmosphere or reducing emissions from our systems. Okay, this is just a depiction of communities participating in the agroforestry activities. This was pictures taken in Zambia. Then the aspect of changing our agricultural systems to reduce emissions and promote sequestration of carbon. This is like a pilot conservation agriculture where it promotes cooperation of your crops over and reduce tillage. Tillage, when you're tilling the land, you're promoting your CO2 emissions. Conservation agriculture one is which under the LULUCF interventions is cheap to implement in terms of minimum tillage, reduced fuel consumption. Once it's established well, you have higher yield because of your improved soil structure, improved microbial content in the soil, and therefore improved nutrient availability and water holding capacity. You have a smaller farming area that would reduce the desire to deforestate and expansion of land. The aspect of skills transfer in terms of agricultural technology promotes the skills transfer to local communities. Then can grow into beyond subsistence farming. Farmers would be able to produce crops, the yield that they can get into semi-commercial or commercial operation systems. And the other aspect contributes to avoided deforestation, that farmers won't be have that desire to expand land, because within a small area they will be produce food for their households. All right. So conservation agriculture, right under the reduced emissions and deforestation. Typically, soil tilling practices, conventional type, results in soil degradation, loss of biodiversity, be it microbial biodiversity. Then the tillage also results in a spread of pests and diseases, as well as reduced soil productivity, because there's a loss of soil structure as you continuously till the land. Hence, conservation agriculture seeks to address that, reverse that. Reduced tillage, on the other hand, it promotes reclaim more carbon into the soil, and carbon in the soil is good for all your saprophytic microorganisms. And these microorganisms they help release nutrients, whether you're looking at a phosphate cycle, nitrogen cycle, carbon cycle, and so they help nutrients become available for the crop and therefore support the crop growth. Other nutrient availability also helps the improved soil structure, soil water holding capacity, and hence provide the best suitable growing environment for the crop. All right, so adaptation is fine. We can do whatever mitigation, but climate change is here. We just need to adapt. What does adapt means? We're able to live with the negative impact of climate change. This depiction here is like a drought. Water bodies dried and no water. So it means you have to find alternative sources. All right. The aspect of adaptation in terms of facilitate appropriate land use, such as where to farm, what to farm with, and where to cycle. type of livelihoods in terms of how do we survive in like smaller farmers, the aspect of drought-tolerant animals, drought-resistant cultivars, synergistic and complementary to ecosystems, and that is how do we utilize our ecosystems so that we integrate sustainability. You know, for instance, we want to talk about ecosystem services. So your forest help in the hydrological systems. They also help in terms of production of biodiversity, in terms of biological control, insects which they survive in the natural ecosystems and they can be incorporated into your agricultural systems. And then we have the aspect where we're looking at specifically agriculture. We have, you know, water tolerant cultivars, those which are looking at your floods. If you're more flooding area, you might actually consider your paddy rice, you know, flood production systems of rice instead of your traditional upland crops. The aspect of drought-resistant cultivars, or combination of various systems like your conservation agriculture and agroforestry systems. These conservation agriculture and agroforestry is systems which seeks to mimic natural ecosystems, where you're looking at, you know, the synergy. There's complete nutrient cycle. There's minimum loss of nutrients or disruption of natural systems like a forest continuously being intact. Right. What is tomorrow's agriculture? You know, it's a choice. Whether we want tomorrow's agriculture, I'll use the term continue with the dirty agriculture, or we choose to do clean agriculture. What I mean by dirty agriculture, increasing the use of genetic modified crops. Why is it considered, or why as an individual I consider it as dirty aspect of genetic modified crops is introduction of foreign genes in ecosystems. The danger of foreign genes in ecosystems, if they cross over into natural weeds or other crops, which becomes difficult to manage, you know, either being resistant to pests and diseases, because they've had most of our crops, they have relatives in the wild. So if there's a crossover of genes, like drought-resistant genes or disease-resistant genes and whatever, means we have super weeds into our systems, and that is an issue which we would not want in our system. Increase in the use of inorganic fertilizers. You know, we're continuously being bombarded with increased use, although there's an aspect of precision agriculture which we might look at reducing these organic fertilizers, but the just desire to increase with the global world population that will be expected to increase. Of course, there's an increase of use of agro chemicals. And what is the negative impact of these systems? The loss of local control of crop seeds production systems. When you're looking at genetic modified crops, there are one or two companies, global companies, and that will be controlling food security in developing countries, and that instead of providing food security, actually be promotion of insecurity. It means communities are not able to retain their genetic materials, then they have to have cash to buy the GMOs, and they have to have cash to travel to get GMOs from nearest seed producer, as opposed to a natural seed production system where communities retain, particularly with open pollinated varieties. Right. So there's also loss of indigenous foods, plant genetic based loss of biodiversity, natural ecosystems. When you go to in a forest, there are a lot of natural indigenous vegetables, indigenous foods, indigenous insects, which form is part of a food base for most of our communities in the tropics and subtropics. So if these are lost through excessive use of chemicals, deforestation and other stuff, that is a negative impact. And that's why we strengthen my consideration of the above systems as dirty agriculture. The environmental pollution. Imagine the herbicide agrochemicals which are sprayed in the agricultural production systems, and most of our fields are in the water catchment areas. All these chemicals flow into our water bodies, be it rivers, dams, and then eventually find their way into underground water. We have concerns, herbicide like atrazine, which has been considered or thought of or established that there's a carcinogenic effect if consumed. Atrazine can survive in the underground water up to a period of 2 years, and so it is an issue which we of major concern about it. So automatically it affects human health. Contaminated food, water, it affects also your animals, your biodiversity in your water systems, where you're looking at your fish, your crocodiles, and once there's a water pollution, it means it affects all the life in your water systems, both terrestrial and aquatic, which is not what we desire. Okay, so let's talk clean agriculture. What is it we consider clean agriculture? One would look at organic farming, or preferably some people call it regenerative agriculture. Organic farming is the opposite of the above. You want to eliminate or totally remove your inorganic fertilizers or use of agrochemicals, and use organic programs, which are safe to the environment, no pollution, no loss of biodiversity. The other intervention is you're looking at precision farming, where you reduce your amount of fertilizers, you apply the right place, right amount, minimum, without with the minimum pollution to the environment. Then there's the aspect of new clean technology. This could be the aspect of management of your soil. We're looking at the soil health aspects in terms of your soil sterilization. Instead of you using the traditional methyl bromide, which has been removed because of high amount of methane emissions, you're looking at other technologies which does not pollute the environment. Okay, so what is the issues on organic farming, regenerative agriculture? Maybe I'll just give an overview. Many people don't know the true meaning of word organic. Some take it to mean natural, pesticide-free, and local use of local materials. Others take it to mean certified to the utmost degree. And then for our purposes here, we would define maybe organic is the term, labeling term that indicates that food or other products have been produced through approved methods of production. And these would integrate your cultural, biological, and mechanical practices that promote cycling of resources, promote ecological balance, and conserve biodiversity. So that would, maybe speak to the aspect of regenerative agriculture. So that is reduced synthetic fertilizers, the aspect of sewage, sludge, irradiation, genetic engineering may not be used under this system. Then organic farmers, what do? They sustain ecosystems, they reduce pollution, be it water pollution, land pollution, air pollution. And we're looking at improving both production and quality of nutrition, which is linked to improved social and economic viability of our communities, especially in the developing countries where these communities are being challenged or put under pressure because of the aspect of climate change. All right, so what are the approved methods? Include the aspect of that irradiation, sewage, synthetic fertilizers, fertilizers prohibited and genetic organisms were not used. Pesticide, if used, must be derived from natural sources, organic pesticides. These pesticides might be applied using equipment that has not been used to apply any other synthetic materials for the past 3 years. So it means there's minimum chance for contamination with the chemicals if you're using organic pesticides. The land being planted cannot have been treated with synthetic materials for that period either. Okay, then your meat producers met animal health and welfare standards as stipulated in terms of organic production systems, that is, did not use antibiotics or growth hormones, used 100% organic feed, and provided animals with access to outdoors, that sort of house or pen feeding, which with no exposure to natural production systems. Okay, so what's the future of agriculture in South Africa? Well, the aspect of strong government policies to guide the production systems in terms of also research programs that would have clarity on the GMOs, use of GMOs. Then the aspect of a policy on the water use efficiency programs, because the South Africa is facing drought, persistent drought on an annual drought, and it is bound to continue. South Africa and Sub-Saharan Africa in general, or SADC region, being more specific. And with now the climate change, agriculture adaptation programs, which need to be employed. Then approaches with the spelling of adaptation. Then we have promotion and development of indigenous crops. These indigenous crops, they have an advantage that are already adapted to the local conditions, and therefore will easily adapt as opposed to the exotic crops. Therefore, this is the feature which I think the policies of agriculture should, policy development should seek to develop and address. My presentation, this topic ends here today, and then we want to thank you very much for listening.